Okay, good day everyone. So we will be discussing about um, hydromechanics in marine engineering. So how does this affect our um, course, our ships? Okay, so let's start. Okay, so we have the learning outcome: solve problems involving application of hydrostatics in marine engineering. So we will start now. So makita natin sa video or sa background natin, we have hinati yung dagat um, ni Moses. So, ito yung gagawin din natin sa ating um, mga utak. Hatiin natin yan. Hindi pala. Okay, so let's go. These are topics for hydrostatics in marine engineering. We have the liquids with different densities, submerged and floating bodies, pressure head, manometer, center of pressure, hydrostatic force, hydrostatic application, marine engineering with the bunker weight computation, bunker mixing computation, hydrostatic load on ship structures, and pump heads. So, we will discuss this one by one. Okay, we'll go with the first topic. Liquids with different densities. Okay, so what is density? Density is defined as the mass per unit volume of a substance, represented by the formula P is equals, density is equals to mass over volume. Okay, so what are the factors affecting density? We have temperature. So as temperature increases, density decreases. So these are, they have inverse relationship. So with salinity naman, so as salinity increases, density increases, and with pressure increases, density increases. Okay, so there is also a relationship between viscosity and density. So since we are talking with density, so we should relate na rin natin sa viscosity natin. So viscosity is the resistance to flow. So the viscosity of water increases as density increases. So it doubles as temperature decreases. So from 25 degrees Celsius to degrees Celsius. So bakit natin pinag-aaralan to? Of course, because in ships, we do have fuel oils, we have lube oils. So viscosity is very important, especially sa fuel oil, because the viscosity is proper viscosity is used para maganda yung injection ng ating fuel to inside our engine or combustion inside our engine. Okay, so this is an example. So viscosity, temperature dependence. So we have here the viscosity and we have the temperatures. Habang tumataas yung temperature, bumababa yung ating viscosity. Okay, so in this diagram, as you can see, we have here the permissible injection viscosity, which is 10 to 12 centistoke. So this is the permissible injection viscosity for this diagram for a type of engine. Okay, so if ever you have different, of course, you have different types of fuel. So if ever you will be using the IFO 380 or HFO, heavy fuel oil 380, so you should be having a temperature of around 130 plus, so around, let's say, 138 degrees up to 145 degrees to maintain the injection viscosity of 10 to 12 centistoke. Okay, this is the part with the shaded part. So that is our injection viscosity na set point. Okay, so ganun kataas. So around 138 to 145 degrees Celsius. Okay. So if you will be using a much lighter fuel, which is IFO, intermediate fuel oil, IFO 80. So in here, maybe let's estimate around 108 to 115 degrees Celsius. So a lesser number. Okay. So depending on your fuel that you will be using, there are different temperature that we will be required to use to have a proper injection viscosity for our engine, for during injection, during combustion. Okay? So, yun. Okay, next. So, effect of density on buoyancy. So, density and buoyancy force. So, Archimedes principle, a body submerged in a fluid experiences an upward buoyant force equal to the weight of the fluid displaced. So, makikita natin dito, we have the red part of the ship. So, this is the displaced body. So, ito yung nakalublob na body ng ship. So, kung gaano ka bigat yung nakalublob na body of the ship, that is the amount of liquid na na-displace ng ating barko. So, that uh, that displaced water will be um, will put in upward force, also known as the buoyant force, para yung barko natin is lumutang siya. Okay, so we have a representation here. So the W, buoyant force or weight of the fluid displaced. So yung buoyant force mo or yung weight ng na-displace mong tubig ng barko is equals to, so the formula will be equals to the density times gravity times volume. So there is a certain volume ng barko na sa barko na dinidisplace mo yung liquid mo o yung dagat. Okay, so buoyancy in seawater versus freshwater. So as you can see in the diagram or in the illustration, so mas madaling lumutang sa saltwater kaysa sa freshwater because of density. So ano ba yung density? So yung density ng freshwater is 1,000 kg per cubic meter. And then since mas mababa yung kanyang density, so yung buoyancy din niya is mas mababa. So, mas mahirap lumutang dyan. Di tulad ng saltwater which is around 1,025 kg per cubic meter of density. So, the buoyant force will also be different, which is higher than fresh water. Okay. Next, implications for ship design. So, makita naman natin sa barko, we have this, the plimsoll line. This is the plimsoll line. So, ito yung nandito. Okay. Habang dito naman sa other part of the ship, we have the draft. So, ito yung gano'ng lalim na yung nakalublob sa barko. And then, we have the plimsoll mark or plimsoll line. Okay, so, sa plimsoll line, meron dyan nakasulat. For example, pag nasa seawater ka, tropical zones, so usually, yung tubig is, since mas lutang yung barko mo, kasi yung density mo is mas mataas sa seawater, so around dito yung level ng tubig mo. Pero pag nasa mga summer or na mga lugar ka, mas mainit yung temperature. So nagbabago din yung density, nagbabago din yung buoyancy. So around here na yung lubog ng barko mo. Pag nasa winter load line ka naman, nandito naman yan. And winter North Atlantic load line, so mas malamig, so ganun. Habang pag nasa freshwater load line ka, around nandito yung mga lubog ng dagat mo, yung tubig. Pero pag nasa tropical freshwater load line ka, so nandito ka sa TF. Okay, so it depends kung saang lugar ka, kung nasa river ka, freshwater, or nasa seawater ka, sa ocean, sa Indian Ocean, or sa Atlantic Ocean. So depende, so meron siyang specific na density, and then meron din siyang specific density and buoyancy pala. Okay, next we'll go to the metacentric height, so also known as a measurement of stability, so GM, or metacentric height. So if G, yung G mo is below M, M is the metacentric metacenter mo. So if G is below M, then the ship is said to have positive metacentric height. So yung G pala is ito yung center of gravity ng barko mo. So diyan nakatutok lahat ng bigat. Nandiyan yung center of gravity. Okay, so pag nasa baba yung metacenter, nasa taas yung metacenter, nandito sa baba yung center of gravity mo. So sabihin na natin yung these are ang tawag dito imaginary lang ito. So hindi ito nakikita sa barko na may G laging may G na dumadaan doon, charap. Okay? So these are just imaginary. So to make this simple na lang, okay, so yung M natin, ito yung parang pivot point ng ating pendulum. Okay? So, pag yung pendulum mo, nasa ilalim yung bigat, yung G mo, nasa ibaba. So, yung sway or yung weight is nasa ibaba. So, nasa ibaba lang din yung pendulum. Di ba? Pero, for example, yung G mo, which is the center of gravity, is nasa taas ng ating center of yung pivot point natin nasa taas. So, may tendency na yung G mo is babagsak sa ilalim. Okay? Pag bagsak sa ilalim, ikot yung barko mo or matutumba yung barko mo, magiging mawawala yung stability niya. Okay? So that is in simple layman term na lang. So about metacentric height. So the difference between G and M, so that is your metacentric height. So mas layo sila, mas taas yung stability mo. Pero mas malapit, mas maliit yung metacentric height or magne-negative yung metacentric height, so yun, magiging delikado na sa barko mo. So parang magiging ganyan. Okay? So sabi ng barko, minsan okay lang din naman magpahinga. Di ba? Pahinga lang, sandali. Pero balik ka naman, bounce back agad. Okay? Sige, so we have an example problem. So this will be a simple lang naman to. So buoyant force or ating W is equals to density times gravity times volume. So given naman yung volume niya is 5,000 cubic meter of water. So times mo sa, depende kung nasa freshwater or seawater. So volume times density times gravity. Okay? So yun, makuha mo yung buoyant force mo or yung weight of the fluid displaced. Ito yung W or ito yung F buoyant or buoyant force. So gamitan mo lang calculator, madali lang naman yan. Okay, next. So that's it. That's it for our first video, which is densities. Okay, so up next we will be discussing about submerged and floating bodies.